Algebra 2, this is Chapter 4, Section 7. We're going to talk about identity and inverse matrices, but mostly the inverse matrices. So let's get started with this. So first of all, we need to figure out determine if an inverse of a matrix exists, and we need to be able to find the inverse matrix. So let's start with what the heck is an inverse? Well, let's start with multiplication. And if I have, I'll put my markers here. Multiplication, if I have 6, then the multiplicative inverse would be 1/6, because whenever I multiply 6 times 1/6, I get 1, which is the identity. So when you multiply together things and you get the identity, you're multiplying inverses of each other. So if I take 2/3 and I multiply that by 3/2, that would be 6/6, or 1. So these two would be inverses of each other. Likewise, we've got addition. If we've got 7, then the additive inverse would be -7. And when you take 7 minus 7, you get 0, and 0 is your additive identity, because when you add 0, you get yourself. So I could also have -4, and the inverse of -4 would be a +4, because when you add -4 and +4, you get 0. So we need a matrix that would give us the identity matrix, when we multiply by itself. So what would be the identity matrix? Well, that's pretty easy. The identity matrix is 1, 0, 0, 1. On a 2 by 2. On a 3 by 3, it's a 1, 0, 0, 0, 1, 0, and a 0, 0, 1. Your diagonal is going to be 1s. And you can only have an identity whenever it's a square matrix. So these would be your identity matrix, and we'll need to go figure out how to get the inverse out of that. So let's look at these two matrices and see if they are in fact inverses. Remember, inverses give us the identity, so if it's a 2 by 2, we're looking for this 1, 0, 0, 1. So when we multiply this one, we're going to take this column by that row. So half of 2 is 1, and -1 times 2 is -2. And then you're going to take this column times that row, and half of -1 is going to be -1/2. And then 1 times 4 would be a -4, so we are going to subtract 4. Okay, so far so good. Let's keep going. So now let me change colors. Now I'm going to take this column, second column times the first row. Half of 2 is 1, plus a fourth of 2. A fourth of 2, so that's 2 over 4, so it's 1/2. And then we're going to take the second column times the second row. Half of -1 is -1/2, and 1/4 of 4 is 1. Then we want to simplify this, and we can see right away this is not going to give us that 1, 0, 0, 1. 1 minus 2 is a -1. 1/2 plus 1 is 1 1/2. -1/2 minus 4 is -4 1/2. And -1/2 plus 1 is -1/2. This is not even close to the identity, so these are not inverses of each other. Take a look at another one. Okay, so we're going to take 1 times 3. 1 times 3 is 3. And -1/2 times 4 is -2. Looks like we're starting out pretty good. 3 minus 2 is 1. So we're going to take this 1/2. 1 times 1 is 1. And 1/2 of 2 is -1. So that does give me the 0 right here. So far so good. Changing colors again. Second column times the first row. -2 times 3 is a -6. And here we go. 4 times 3/2. So 4 times divided by 2 is 2. 2 times 3, this is going to be 6. So it's going to be +6. And that is our 0 that we wanted. This is 0. And then this 2 and 3/2 times this 1 and 2. So -2 times 1 is a -2. And 2 times 3/2 The 2's cancel, and that is 3. So that's going to be a plus 3. So negative 2 plus 3 is 1, and this is the identity. Are they inverses? Yes, they are. Okay, so notice this is 3, 4, 1, 2, and 1, negative 2, negative 1 half, 3 halves. I'm going to grab the same exact matrices, but now I'm going to multiply y times x. So I'm going to put them in the other order. So maybe it would be easier if I wrote them this way. Right? So same thing, I'm going to take this 3 times 1 and this 1, 2. So 3 times 1 is 3. One times negative 2 is negative 2, so I get a 1. Then I'm going to take the first column and the second row. So 3 and negative a half, when I multiply them, is negative 3 halves. And 1 times 3 halves is positive 3 halves. So that is 0. And then I can take my second column. 4 times 1 is 4. 2 times negative 2 is negative 4. So that's a 0. And 4 times 1 half would be a negative 2. Half of 4, 2. And 3 halves times 2 over 1 would be 3. So that's plus 3. And that gives us the 1. So whenever I flip the order and I multiply them, I still get my identity matrix. They are inverses of each other, so you should be able to change the order and still get your identity.